Okay, so we have this interesting question here. X over 18 equals 2 over 3 all in bracket log 12 to the base x. So how do we solve this question? So let's see how we are going to do it here. So we have it written here to x over 18 equals 2 over 3 all in bracket log 12 to the base x. So what you can do here is, first of all, you can log both sides. Log to the base 10, add log to both sides. So this will now become log base 10 x over 18 equals this one also log base 10 2 over 3 all in bracket, the power still remains there, log 12 base x. And then you can still have it this way, log base 10 x over 18 equals the power for the number here comes in to this side to stand in product form, with this log here. So this one comes over here to become log 12 base x to be in product with this one dot log 2 over 3 base 10. So that settles it. This is from one of the laws of logarithm. Then we have it this way. Then we can now simplify the left hand side. That's this part of the left hand side and this part of the right hand side. Remember that log a to the base 10 minus log b to the base 10 gives us, we're going to use division rule, write your log base 10 and then you divide the numbers because it is subtraction. So what we're going to do, we're going to reverse this back to something like this. So this and this are in the same pattern. You have your log a over b, this is log x over 18 base 10. So if log a over b can be reversed back to log a base 10 minus log b base 10, I'm going to do the same thing here. This one becomes log x base 10 minus log 18 base 10, exactly what was done here. So this one becomes log x base 10 minus log 18 base 10 minus equals log 12 base x. Open bracket, I'm doing the same thing here because log 12 base x is in product with this whole expression. So the same pattern again is still here. Log 2 over 3 base 10, log a over b base 10. If I can reverse this to log a base 10 minus log b base 10, I'm going to write this one as log 2 base 10 minus log 3 base 10 if I'm reversing this back. So this one now becomes log 2 base 10 minus log 3 base 10, then you close the bracket. And then you can have, we can do change of base here. So here we can do change of base. Remember change of base, if you have log a base b, it can be written as log a base 10 over log b base 10, change of base. So log a base 10, then log b base 10. So that's what I'm going to do here. So we now have log x base 10 minus log 18 base 10 equals to, I'll do the same thing here. So now becomes log 12 base 10 over log x base 10. Still open your bracket because it is still in product with this whole expression in the bracket. Log 2 base 10 minus log 3 base 10. And then since this is in fraction form, I can multiply through by log x base 10. So times, I'll multiply everywhere this part. Since this is a single term, I'll multiply this single term by log x base 10 to eliminate the denominator of this fraction. So it just be just a straight equation. Then times log x base 10, and I'll multiply here too by log x base 10 and here too by log x base 10. So times log x base 10, then here times log x base 10, and also here 2 times log x base 10. So this cancels out this. So we now have log x base 10 times log x base 10 gives me log x base 10 all raised to power 2 minus log x base 10 times log 18 base 10 just gives me log x base 10 dot product, that's times log 18 base 10. We can leave it this way for now. Then equals, this one is just log 12 base 10 left since we've eliminated the log x base 10. So log 12 base 10, still open your bracket, still have log 2 base 10 minus log 3 base 10. And then we can, if you notice that we have log x base 10 common on the left hand side, so we can say let log x base 10 be p. So let's just make it p. So say let log x base 10 be p. So we now have this log x base 10 is now p. So I have p raised to power 2. So that's p raised to power 2 minus p. This is p log 18 base 10 equals log 12 base 10 open bracket log 2 base 10 minus log 3 base 10. And then if you are very observant, this has led to a quadratic equation. So I'm taking every term to the left so that the 0 will be at the right hand side, just like how you have a standard quadratic equation. So based on this, let's do that. So we now have, bringing everything to the left, these ones are already on the left hand side. So I have p squared minus p log 18 base 10. Then this whole term comes over and becomes minus, because you have a plus sign here already. When it moves, when this whole term moves to the other side, it becomes minus log 12 base 10 open bracket log 2 base 10 minus log 3 base 10 close bracket equals 0, because there's nothing on the right hand side again. So we can solve this using a quadratic formula. So solving using the quadratic formula. Okay, and what's the quadratic formula? Since the p here is our unknown, I can say p equals minus b plus or minus root b squared minus 4ac everything over 2a. So I will just replace, and since this is a quadratic equation, the coefficient of p, which is log x log 18 base 10, is my b. So anywhere there is b, I'm putting log 18 base 10. Coefficient of p squared, which is 1, is my a. So anywhere there is a, I'm putting 1 there. Then the constants here, this one doesn't have any variable at all. This whole value here is my constant, so I'm using it to replace c. So let's go on. So we have it this way. Yes, we now have p equals minus open bracket log 18 base 10. Oh, there's even a minus there already, so minus minus. Let's be careful there. This minus here is the one here, and the minus here is the one in the equation. Then plus or minus. Make this one longer because fix long values there. Then this will now be minus log 18 base 10 squared minus, let me put these ones in bracket, 4 times 1 times, this is my c and it has a negative sign, so times minus log 12 base 10 open bracket, be careful there, log 2 base 10 minus log 3 base 10 close bracket, close bigger bracket. You have to be careful. Everything over 2. So let's now get this the values from log 18 base 10. So using your calculator or using your four-figure table, we can get the values of log 18, log 12, log 2, and log 3 using your calculator or your four-figure table. So, and anything you get must be rounded up to 3 decimal places, or 4 decimal places rather. It should be 4. So we now have P equals minus, open bracket, minus, the value for log 18 base 10 will be 1.2553 if you use your calculator, 1.2553, or you use your four-figure table. You have plus or minus square root, again minus log 18, that's minus 1.2553 all squared, minus 4 times 1 is 4 times, okay, this one is now minus log 12 base 10 will give us 1.0792 if you use your calculator, 1.0792 bracket, log 2 base 10 will be 0.3010 minus log 3 base 10 will give us 0.4771, then you close the bracket. Still everything divided by 2. Everything divided by 2. So, simplifying this, you now have P equals minus times minus is plus. So you have just 1.2553 plus or minus, then your root. So minus 1.2553 raised to power 2 will definitely give me 1.5758. If you use your calculator, 1.5758 minus, I have 4 times 4, there's a plus sign here, so plus 4 times minus 1.0792, that is going to give me minus 4.3168, minus 4.3168, then open bracket. If you subtract, you get minus 0.1761. If you subtract this from this, minus 0.1761, yeah, then you close the bracket, and then still everything divided by 2, and then I have P equals 1.2553 plus or minus, again root, I have 1.5758, minus and minus is plus. Let me first fix this minus here first, then I'll deal with the one in the bracket. Minus and minus is plus, that's plus. Then 4.3168 times 0.1761 gives me 0.7602. 0.7602. Everything still over 2. And then, wow, the solution is long. So we now have it this way. Of course, we now have P equals 1.2553 plus or minus root 1.5758. Minus times plus is minus, so you now have 0.7602, everything over 2. If you subtract this from this, you get 0.8157. So you now have P equals to 1.2553 plus or minus. If you subtract, you now get root 0.8157, 0.815, okay, you get 56 rather, 0.8156 over 2. Then we can find the square root of this using your calculator. We now have P equals 1.2553 plus or minus square root of 0.8157 will now be 2 point let's say 2 points. It gives you 2 points, or rather, let's just separate them. We can say P equals 1.2553 plus, write the one with plus first of all, plus root 0.8156 over 2, or we use the minus sign now, 1.2553 minus root 0.8156 everything over 2. Simplifying this with your calculator, you end up getting P equals 1.0792, or you get 0.1761. So, but since you have gotten a value for P, we remember we made P to represent something. So we said that let P be what? Log x base 10. So we're bringing log x base 10 back to the problem. So we say but P equals log x base 10. So we can now say log x base 10 equals P, which is 1.0792. And of course, we now have 10 raised to the power. This must give me my x. So you see x equals 10 raised to the power 1.0792. You now have your x to be approximately 12. This is the first correct solution to the equation. Then the second one, the same thing. We have P equals 0.1761. And then we know that P equals log x base 10. So you now have log x base 10 equals 0.1761. And of course, 10 raised to the power, this must give x. So you now say x equals 10 raised to the power 0.1761. And then we now have x equals, if you use your calculator, 10 raised to the power, this gives us approximately 1.5. So that's it. And these two values will satisfy the equation and make it true. So that's it.